Friends, I have taken question number 8, section 1.1 from IRODOV. Let us discuss this problem. The problem is two boats A and B move away from a buoy anchored at the middle of a river along the mutually perpendicular straight line. The boat A along the river and the boat B across the river, having moved off an equal distance from the buoy, the boats return. Find the ratio of times of motion of boats tau A divided by tau B if the velocity of each boat with respect to still water is n is equal to 1.2 times greater than the stream velocity. So in the question it is given there is one buoy. From here two boats starts. One goes with the stream velocity, let's say Vs, and the other boat B goes exactly across the river. So now for B to go exactly across the river, B will have to keep his velocity in this direction. So VB plus Vs should be in this direction. The resultant should be in this direction. Right? In the question also it is given that both boats is traveling to equal distance in their directions. So let us say that distance is d, and then it returns back to buoy. Okay. So what we have to, both the times will be different, right? So boat A will take certain time, that is tau A. Boat B will take certain times, that is tau B. So ratio of that we have to calculate. Okay. So let's start. For boat A first is going downstream, means along the stream. So what will be the speed of boat? V. If we say the speed of boat is V in the still water, so its speed while going downstream V plus Vs, and upstream when it comes back V minus Vs, right? So it has traveled a distance d. So what time it has taken to travel a distance d downstream? That will be d by V plus Vs, correct? Then it is coming back again to buoy, so it has to cover a distance d again against the stream. So that time will be d V minus Vs. So this is your total time taken by boat A. Now concentrate on boat B. What is the magnitude of the resultant of boat B? The velocity resultant is Vb square minus Vs square, right? Right? In the question it is given that both the boat has the same speed. So Vb is equal to Va is equal to V. Let's say V. Okay? So with this speed it is going d direction, in the d direction with this velocity. Okay? Sorry. With this velocity it is going across the river and covering a distance d. So what will be the time to reach d distance? That time will be d by magnitude of this that is VB square minus VS square under root. While coming back, it comes exactly the same way to boy B. So how much times so going up and going down, the time will be same because resultant speed to be on this path for both B will be same. So this is your tau B. VB is nothing, VA is equal to V, so we are writing like this, V square minus V square 2 times half. So this is tau B, right? Question is asking tau A by tau B. We have to simply divide it. This one, if you extend further, what is coming? D, VS will cancel out, so 2 into V time, and this will be V square minus VS square. Correct? So put this value over here, 2VD divided by V square minus VS square into tau B's 2D V square minus VS square under root. 2D is finished, cancel out. So V, this under root, and this. So this will become V square minus VS square under root. Now divide it with Vs, with the stream velocity. Why? Because it is given that n is equal to V by Vs, that is 1.2. So to express in the terms of n, because that is only the known quantity, this is only the known quantity in this. So this will be the answer. You can put the value of n and you can calculate. Thank you. If any issues in understanding, please write in the comment box. I will come back. Thank you.